All right, hello everyone, and welcome to the Convex community call. So as usual, we have a call every week where we discuss some big ideas in the Convex community, and open to questions and discussions. So if you have any questions, fire away on the live chat. I promise I'll try and pay as much attention to it as I can while trying to go through some of the things that we want to discuss today. Um, so today the topic is the asset model that we're building in Convex, and particular the design that we're taking towards building a universal model for digital assets. And I wanted to explain a little bit about why I think this is important and valuable. So what's interesting about the digital asset space is loads of different ways of representing assets have been created. Yeah. And that's not a bad thing. It's great that we've got lots of different innovations. So, you started with obviously the original Bitcoin, where you've got an asset defined as sort of a native currency on a proof of work ledger, was the sort of the original decentralized digital asset. And then, of course, you've got Ethereum, you've got lots of other kinds of networks have their own native cryptocurrencies. But when we talk about the universal asset model, we're not really interested in those sort of native tokens. We're talking about what can users or developers or businesses create in terms of digital assets on top of the platform. Yeah, and that's a very important distinction. The native cryptocurrencies, the native tokens that power these networks are very, very specific to the functioning of the network. Whereas what we actually want to enable in terms of the ecosystem and in terms of what people can do in decentralized economic systems, we want to allow people to create their own digital assets of any type, of many different varieties, and for many different possible use cases. And we want that to be as free and open as possible. Yeah, everyone should have the right, in a sort of self-sovereign way, to develop their own digital assets and have those as an exchangeable, um, currency, or as a token, or as a voucher. Whatever people want to create ought to be possible. Everyone should be able to do it. Everyone should be able to do that efficiently, and everyone should be able to build the kind of decentralized economic models that they want based on those tokens. And one of the key purposes of Convex as infrastructure is to enable people to do that as efficiently and as effectively as possible. Hence, of course, we need to design a way of generating and managing digital assets that works well for all of these different use cases and opportunities that people might want to build. And that's what we call the asset model, the Convex asset model. And I guess it's important to draw a slight contrast with the Convex asset model. Really is a universal model. It's designed to represent all kinds of assets. So if you're used to perhaps working with some other blockchains, you might know, for example, Ethereum has an ERC20 standard, which was a standard for fungible tokens. That was like the original token standard on Ethereum. But it also has lots of other ERCs. So you've got ERC 777, you've got ERC 721, you've got standards for non-fungible tokens, and they all have a slightly different API and an interface for interacting with these different types of assets. Now, I think it's good that there's innovation in the space, but it also creates a problem for users if you have to hard code your application or your tools to use a particular asset standard every time. It does create extra complexity. And if you've got to support 10 different types of tokens or 10 different types of ways of interacting with tokens, it can be a bit challenging from a sort of development perspective and from the point of view of writing efficient code. So what we wanted to do in Convex was to create a model that was a little bit more universal and would sort of work for all kinds of assets and wouldn't really depend on the implementation, how the asset is implemented. So you can almost think of the Convex asset model as being like an abstraction layer. Yeah, it's like a standard way of working with assets that works regardless of how the asset is implemented. And it's probably best to actually go through this with a few examples and sort of shows how it works. But a motivating idea is, well, what's really different about a fungible token and a non-fungible token? I mean, they're both assets, yeah. Now, one might be represented by an ID for a non-fungible token. Another might be represented by a sort of a numerical quantity for a fungible token. But they're still assets that can be transferred, that can be moved around. You might want to know what assets you hold or control, etc. So the universal asset model is designed to work with all these different types of assets. And we sort of came to a realization that if you think about digital assets, you can sort of specify a digital asset with two different things. One, it needs some kind of identifier that relates to how you interact with it. Yeah, what is the logic of the asset? What is the code, if you like? It needs a way to identify what is the asset, what is the rules that asset employs. And the second thing an asset needs is a way of representing a quantity of that asset. And obviously, for fungible tokens are the most simple example. A fungible token is represented by an integer value, 0 or above. Yeah, so I can have 0 tokens, I can have 10 tokens, I can have a billion tokens. So that number is a quantity. But a quantity of a different kind of asset might look different. Yeah. So here's an example of if you're talking about NFTs. Well, a quantity of NFTs. What is a quantity of NFTs? I mean, just saying the number of NFTs isn't enough. You need to, because they have individual identity. So the quantity of NFTs is actually a set. Yeah, I might have a set of NFTs. I own NFT number 1, number 77, and number 199, for example. So I own 3 NFTs in terms of number, but it matters which the IDs of those NFTs are. So in fact, a quantity of NFTs is a set of NFTs. Now, it turns out that sets and integers, they're actually the same, they actually follow the same mathematical structure. There's this thing in mathematics called a commutative monoid, which is a very complicated term for something that you can add. Yeah, it's something where you can add things together and subtract things, and it's got a 0. Yeah, a 0 means you've got none of it, and then you can add and you can get any sort of positive value from that. So when you add 2 integers, that's logically easier. 10 plus 20 equals 30. When you add 2 sets, in this sort of sense of adding, the broader sense of adding, you actually create a set which contains all of the elements of the 2 sets that were added together. Yeah, so it's a larger set. And you can also subtract. Yeah, you can take away from a number, and you can take away from sets by specifying which subset you want to remove. And you can take away all the way until you get back to 0. Or in the case of sets, an empty set means you've got nothing in your set. You've got no NFTs. So the convex asset model was sort of motivated by the idea of, okay, we want a way of specifying what the asset is and how much of it or what quantity of that asset exists. And that basically is how the entire thing works. Yeah, you have an identifier of the asset, and you have a quantity which is a value which specifies an amount. And why is this valuable? Well, it suddenly means that you can write code that is universal. Yeah, you can write code that works with NFTs, that works with fungible tokens, that works with higher order assets like security tokens or derivatives or bonds. All of these different classes of asset can work with the same API, the same programming model, and that's quite a powerful thing. So let me just switch over, and I'll go through some examples, and I'll say a little bit more about the design as we sort of go through these things. So if this works correctly. Okay, so what I have here is a REPL. So this is the live coding environment that we can use with Convex, where you type in commands and it just executes in the runtime environment. So for those who haven't seen it before, this lower window is where you type in commands, and this upper window is where you see the results of entering these commands. Oh, sorry, question. Commutative monoid is how you can make 10K NFTs in a set, and they can be individual. How do you mark them as individual? So great question. So let me demo it. Yeah. So commutative monoids, how we can make 10K NFTs in a set. So I'm going to need to pull in a bit of code for this. By the way, this question wasn't prepared yet, but I think I can do this. So I'm going to create import a library, which is the NFT library. So it's called asset.nft.basic, which is the library that enables NFTs, and that library happens to have an address 23. Yeah, and I've given it the name NFT just for convenience. But it's an actor. It's a program running on the Convex network with the address 23. Might move in the future, by the way. So all of this code, if the number may change in different networks, but once it's deployed, once it's there, that's going to be fixed as 23 from this point. Yeah. If I want to create an NFT, I do call. So I'm going to call the actor. The actor is basically a program that's responsible for issuing and managing NFTs on behalf of users. Yeah. So I'm going to call the actor. So I'm going to call the NFT. I'm going to do create, and create needs one parameter, which is some metadata. So I might just put some JSON metadata in here for my NFT. I can use any metadata I want. It's flexible, but it's immutable metadata. Once this NFT is created, it's going to be fixed metadata full time. So I've called the NFT. I've created it, and I've got back an ID too. So when it created the NFT, it says, okay, the ID is 2. Now, if I want to create more, if I want to create more of these, I can give it some different metadata. I get ID 3 coming back. Yeah, so I can do this as many times as I want. I can even create with the same metadata. Yeah, so I'm creating multiple NFTs, and they all get allocated integer IDs as they get generated. Now, if I want to, I'm going to just import the Convex Asset Library, which is really the interface for all of these different assets, which has address number 20 in the development network. And what I'm going to do is I'm going to say, okay, what's my balance? And I'm interested in my balance, particularly for NFTs. Yeah, I don't. So what of this particular NFT actor? How many of that? What do I have? And it's told me a set. So this symbol, this little hash symbol with a curly brackets, is the notation in Convex for a set, and it's a set containing the values 5, 4, 2, 3, and 1, and a closed bracket. So there's 5 NFTs in this in my balance. So I just created 2, 3, 4, and 5. I think I must have created 1 earlier when I was testing things. So I've got 5 NFTs at the moment. If I want to create a lot of NFTs, live coding, I haven't tried this, but let's try. I want to create I want to do a loop 50 times, and I'm going to do call NFT create name Legion and ID I. So this is running a loop, yeah, to create a bunch of different NFTs. See if this works. Oh, it's Mr. Bracket, my fault. Okay, so I think that worked. If I now check my balance, yeah, I've got like a whole bunch of NFTs now that I've just generated. So you can see it's very efficient. It's sort of instantaneous as it sort of deals with these NFTs. Now anyone can do this, but when you create an NFT, you own it. Yeah. So the general principle is that the creator of an asset, digital asset, owns it until they transfer away to someone else. If I'm interested in someone else's balance, so if I can say, okay, I'm account number 12 at the moment, seeing this account here. Um, but I have this window here open for another another account. This guy's address is 13. So if I want to see what NFTs account number 13 holds, he's got a much smaller set. He's got a set just with one NFT, NFT ID 0. Yeah. So let's say I want to transfer some NFTs to this person. So I can say again, I'm using the asset library. I'm using the transfer function. Yeah. So I'm transferring to this other account number 13, and this is where I mentioned the asset model has this concept of what's the asset and what's the quantity. Yeah. So to answer the question, yeah, how do you transfer individual tokens? How do you work with individual tokens? Well, the asset type, if you like, the class of assets is the NFT. So that's the specifier, which is specifying what the asset is. And then I'm going to say a set of what NFTs I want to transfer. So let's say I want to give away NFTs 23, 16, and 55, for example. Yeah. And remember my close bracket, execute that, and I think that's worked. So now if I check the balance now of actor number 13, yeah, he's now got 4 NFTs. So he's got 23, 16, and 55. So those NFTs got removed from my set and transferred to the set of NFTs held by the recipient. Yeah. So this is how you can move NFTs around. If I'm interested in um, let's see, I think it's call NFT. I can get the metadata of any of these NFTs. So if I want the metadata on the asset 55 that I just transferred, for example, okay, so that's the metadata attached. So notice the ID of the asset is 55 of the ID of the NFT, but the ID that got put in the metadata, because I started the loop at 0 and there were already some NFTs, that was the iteration 49 of the NFTs that got created. So that's why those two are different. Um, so yeah, that's everything you need. You've got an asset, you can transfer them, you can send them to other people, but and you can attach metadata. So you've basically got a full set of capabilities here. Now I should not be able to transfer something again once I've already transferred it. So I don't own this asset. So if I try and transfer it again, yeah, so it's failed. Yeah, because I don't own asset number 55. I can't send it, and it's going to error when I try and do that. If, however, I go to this one, balance, what's the NFT 23? Oops. I need to remember to import my library in the other account. 1 second. Import the asset library, so that's 20, and now I should be able to do asset balance of 23. I can see these assets, but I should be able to now transfer it back. Yeah, transfer. Um, I want to transfer it back to account number 12, and so I'm just returning the asset, if you like. And this identifier, I can use the NFT, the sort of the label that I gave it, but I can also just specify that I'm actually interested in the actor 23 being the actor which controls the asset, and I'd like to transfer back the NFT number 55. And yeah, okay, so I've just sent the asset back. So now if I look at my balance, yes, I've got my asset 55 back in my original account. So
Hey,
that's the
Mike,
NFT sub. Yep. Yes. Question.
is it possible then to create a smart contract that does all of this moving back and forth based on um, specific events happening?
Yes, you could. So I would say what you would typically do is you would typically send the assets to some actor or some actor which would hold those assets while the smart contract is underway. Yeah. So here I'm dealing with two user accounts. Yeah. So you can tell they're a user account because I can execute commands directly in the account. Yeah. Um, Now the rule of the asset model is, well, look, only the account which is the holder of the assets can transfer them. Yeah, that's the fundamental rule for an asset. Yeah, otherwise you've got some huge security problems if you break that rule. So only the account holding an asset can transfer it. So if you want to put an asset under the control of some smart contract, what you do is you actually transfer that asset to a smart contract. Let me just try it. Let me just try this. Def con. I'm just going to deploy an empty contract. Um,
Here's a use case I was thinking about. Say I have an event and I want to issue tickets, and people buy the tickets, and they come to the gate and I scan them and I now own their NFT, but I want to send it back to them with a validation that they were there and maybe some added bonus.
oh, yep, yep. So what you would do then in that kind of case is you would um, make it possible to send the NFT to some redemption service. Yeah, that can be an actor, it can be fully on chain, where it receives the token, says, okay, fantastic, I've checked you off the list, you've now got your entry. Um, but then that same actor can maybe recycle that NFT, change the metadata to say stamped or attended or whatever, and then transfer that NFT back to the individual once it's done whatever changes it wants to make. Now, that would require an NFT implementation that with mutable metadata. Yeah. So the NFT implementation I've just used here is immutable metadata. So you could use a different NFT implementation with mutable metadata or with the ability for redemption or some other kind of feature. Um, Now, the beauty of the asset model, of course, is it's universal. It doesn't matter what features the NFTs, the tokens have. It's the same instructions. Yeah, I still use asset balance, and I still use asset transfer if I want to transfer an asset. And there's a few other functions in the asset model, but to be honest, those two are the super important ones. You can do pretty much everything you need to do with those two. The only other thing that I'd say is kind of sometimes required is there is an offer and accept model. Yeah. So you can make an offer where you can say you're allowed to take these tokens, or you're allowing another account to take a certain set of tokens or a certain quantity of coins, um, and then they can then go separately, independently, can take those tokens out of your account. So it's almost like pre-authorizing a transfer, yeah, for another party to complete the transfer. So that's kind of a special case, which is helpful for some kinds of smart contracts that want to be able to do that kind of thing. Um, but in general, just balance and transfer do 99% of everything you need.
So it seems like it has a lot of flexibility.
It is very flexible, yeah. I mean, it's designed to be as simple as possible, but but giving really the fundamental capabilities that you need. What I want to show now is a bit of magic, though, because what we've done is we've focused basically on NFTs so far. Yeah. Let's actually do the same thing, but with a different kind of token. Yeah. So what I'll do is let's do a fungible token. So I'm just going to import. I'll just clear this. I'll import convex.fungible. This is the fungible library, which is basically this is the closest thing in Convex to ERC20 plus Open Zeppelin implementations of ERC20. Yeah. So the fungible library both has some aspects of interacting with fungible tokens, but it also has implementations of fungible tokens, which is what we actually want here. And this is going to be a little bit more sophisticated, because with the NFTs, we were just asking an existing actor to issue us with new NFT IDs. Now, in this case, for a fungible token, we're going to create our own actor to represent the the fungible token and the logic which manages that fungible token. So the way we do this, and I'm going to say, okay, we want to define my coin, which is going to be my new fungible token, and we want to use the deploy instruction. And deploy is basically the command in Convex which lets you create a new actor or a new autonomous account. Now, deploy needs to deploy code. Yeah, so we're actually going to put some code in here, and the nice thing about Convex is because we're using Convex Lisp, it's a Lisp. You can do code generation. Yeah, so I don't want to write all the code for a fungible token. It might be quite a lot of code. It might be 100, 200 lines of code to have a full fungible token implementation. Yeah. So what I'm going to do is I'm going to get the fungible library to write the code for us. So there's a build token command. So I'm going to build a token, and I'm going to say, let's say, I want the supply to be, let's say I want it to be 5,000. And I could this would in fact work just like this, but let's say I also want to make it mintable, so I want to be able to mint tokens as well. So again, I can create some code for minting tokens, so the add mint function, and then I want the minter. So there's a couple of optional arguments you can use. I want the minter to be my own address. So I'm account number 12. I should be the only person who can mint my coins. Let's see if this works. Okay, I think that works. So we've got now a new actor. The new actor has an ID of 60. And I deployed a bunch of code, which the fungible library helpfully created for us. So it's basically code that writes code. which we can do because we have the power of Lisp and we have an on-chain compiler. So all of this is on-chain. Yeah, you don't have to upload any code. You don't have to compile code separately. This can all happen in a single transaction on-chain. But this is a full fungible token. This is equivalent of launching a ERC20 token on Ethereum. And anyone can do this. Anyone can create tokens that they wish. Now, what's interesting is the asset library is going to work with this. So my coin, asset balance, my coin. I've got a balance of 5,000. So I just created the code that created a new asset, and it's also given an initial coin supply of 5,000. I think I can also mint, so I can do asset mint, which is a function, a sort of asset function that works with all kinds of fungible tokens. Let's say I want to mint another 500. I didn't make enough originally. Um, okay, and then it's coming back with 500. So yes, just to confirm, my balance is now 5,500. Yeah. So the asset balance is the same asset balance that I used for NFTs. Yeah. The same function in the asset model lets you access fungible tokens and also non-fungible tokens. So, quick question from Kimuri. Can you give accounts names as words and not just numbers? Absolutely. Yeah. So I do this all the time when I'm working with Convex because it's sometimes hard to remember or to recognize numbers, and it can be dangerous if you just mistype a number in it and you don't want to send stuff to the wrong address. So generally, you don't want to be using raw numbers for accounts. So my address is address number 12. Yeah, so you can always type in address in Convex Lisp and get the address of the current executing account. I can define me to be address number 12. So me, if I just let's clear some of this. If I now type in me in this account, I get back address number 12. And then anywhere that I can use address number 12, I can use just the symbol, the name, the name me. And this is just for convenience. Yeah, I could call it whatever I wanted, but this lets you write code and do things without having to create long strings of numbers and stuff. Likewise, my coin is just an alias for account number 60, where 60 is the actor that we deployed to implement my new fungible token. So if I do asset balance of my coin and I want my balance, I've got 5,500. Yeah, so I'm just using the name as I communicate and work with the system. If I want the account number 13, I could just put account number 13 here. Account number 13 currently has none of my coin. So is there a check to avoid duplicate names? I mean, yes, you can do hello and it says undeclared. Yeah, you get an error if you just put in the name and say undeclared. So you can also use defined. I think defined. Okay. Sorry, I have to quote it because I'm just referring to the name. So hello is not defined, but me is defined. Yeah, so you can check whether whether there is a existing name in the in the namespace. Now, if I do a define, then I will overwrite things. Yeah, so if I define A to be 12, it's 12, and then if I define A to be 17, it will overwrite. Yeah. So if I check what the value of A is, it's the most recent one. Yeah. However, this is convex. Yeah. So we can define new language features. This is going to get uh, a bit into the programming, but I promise I'll keep it brief. I can do a safe define, safe def, let's call it, uh, sim value, and I want safe def to be if defined sim, then I'm going to error fail. Find. Otherwise, define sim value. Don't know. So to see if this works, safe def A18. Okay, so it's failed. It's already defined. If I safe def ZZZ as 18, it works. Yeah. So this is part of the magic of having a Lisp is you can actually redefine the features of the language if you want extra safety or if you want to override the default behavior. So slight aside, but it's a very cool thing that you can do with a convex Lisp. So another question. So if anyone uses the name me in a smart contract, you might be getting some free coins. Well, each account gets its own names. Yeah, and this is a very important point. So me here is 12. But if I go to this other account, so account number 13, and I ask what me is, it's undeclared. Yeah. So the names are um, scoped. They're within the scope of the account that defines them. Yeah. So typically, you just use these names temporarily, and then you delete them if you don't want them, or you use them to set up pointers or links to something that you're going to use frequently. I mean, there's various different things you can do with them, but they are local. They're private to each. They're not private. They're scoped to each account. Yeah. I can actually do this. This is bit of magic, but if I can do account number 12, me, I can actually see what me is defined by as in account number 12, because we are on a public network after all, so you can see definitions that people have created. But the me directly in this account is it's undeclared, so you're safe. So yeah, so you can't affect anyone else by uh, defining a name and trying to override anyone else's name. Each person gets their own unique set of names. You can have human readable names that persist across the global network. So these are persistent. Yeah. So these names are fixed. If you want a more permanent name, yeah, you can use an actor which allocates or manages names. So in fact, the convex name system has human readable names that are available as a service to the whole network. Um, but anyone can write a database or an actor that lets you have your own human readable names or aliases or whatever you want. Yeah, it's a very flexible system. The key point is, yeah, your account is yours. You control what's in your account. It's always optional if you want to then from there go and refer out to other accounts or other actors and see what's happening in the other actors. And you can decide whether you want to use human readable names and sort of create your own aliases, or whether you want to use the numbers and just refer to things directly. We it's an open system. It's designed to give people the freedom to do things in the way that they find most appropriate. And sometimes it's more convenient for humans to do things one way, and more convenient for actors or smart contract logic to do things in a different way, maybe more security focused. So you've got to choose the balance and the trade-off when working with these kind of assets. But yeah, very cool. So Convex has this ability to really function as a global database, and you can put what you want in that database. If it's human readable names, fine. Yeah, if that makes sense for your application or your use case. Okay, so let's actually. This is a good segue into the topic I wanted to cover next, which is back to assets. So we just clear these. So we define this asset number, this my coin, this asset, uh, and this has account number 60. Yeah. Uh, and this is like an ERC20 token. There's nothing wrong with it. It's perfectly good way of representing a token. However, there's a couple of downsides to this approach. One downside is I had to deploy a new actor. Yeah, I had to create a brand new set of smart contract code as an actor, bundle it and deploy it. And yes, Convex made it very easy to do that, but I still had to, deploy something new to the network, and that's going to cost me a little bit of transaction fees. It's maybe a little bit inefficient, especially when many of these fungible tokens effectively they're all going to have the same code. Yeah, I mean, why create new code for hundreds of different tokens that all look effectively the same or functionally equivalent. And there's also a security problem with this. Yeah, like you might trust certain well-known tokens, but why should anyone trust this token number 60 that some random person just deployed? Yeah, and do they want people want to go and analyze the code and say, is this a legit token, or might it be trying to steal my money? I mean, you don't know as a typical user whether this is a safe token to interact with or not. Yeah, and that's a big problem. Yeah, we've seen that mistakes get made, whether they're malicious or accidental, that cause flaws in token implementations. It can cause some loss. It can cause some severe angst. Can cause extreme pain. So, although that's the model ERC20 uses, um, we don't actually think this is the best model in Convex. Yeah. So you shouldn't really be deploying custom smart contract code every time that you want to create a new fungible token. So Convex has a different approach, which is our recommended approach in most cases, is to say, okay, what we want to do is have an actor which acts as a token factory. Yeah, so it's going to be a single actor. It's going to have a single account, if you like, but is able to issue many and launch many different fungible tokens. So kind of like how we had one NFT actor creating many NFTs. I wasn't deploying new code every time I created an NFT. I was just asking the NFT actor to issue me with a new NFT. The model that we recommend for fungible tokens is exactly the same. We have an actor which issues new fungible tokens as you want to create them. So let's just go in and do a little quick demo of that. And I see there was a question about Convex about reserving names, so I will get back to that. But I'll just continue on this train of thought for now because it's kind of important. So there's this actor called the multi-token. The multi-token is a factory actor which mints new tokens. So not quantities of tokens, but entirely new tokens. And this is a super important idea. Yeah. So when I want to create a token with this multi-token actor, I give it a name for the token that I want to create. So let's call it the kebab coin or something. It doesn't really matter what we call it. Any keyword will do. Um, So I've now created a coin called the kebab. Um, Now, if I what I can do now is the asset library. Let me check my balance, and here I say, okay, I'm interested in the asset which is created by the multi-token. So the multi-token defines the asset, and the particular one I'm interested in is the kebab coin. And my balance is zero of the kebab coin. But because I was the creator of the kebab coin, I should be able to. Um, Actually, let's just define it. Let's just define kebab because we're going to use this a few times. We define kebab to be the vector, which is multi-token. Yeah. So that is the identifier of this fungible token. Yeah. So the kebab is multi-token with the keyword kebab. Um, and then kebab, you see, that's just a definition in my namespace. So if I do asset balance, I can just use kebab now as a convenient short form for that vector and get the balance of zero. Now I can also mint. So the multi-token allows me as the creator of the token to be the minter. So I can do let's say 1700. And if I check my balance again, I've now minted 1700 of the new token. Now, all of the features are exactly the same as with just creating a regular fungible token with its own smart contract. But here, I've created a new fungible token with no new actor deployed, no new smart contract, no coding. All I've done is ask this factory to give me a new token, and that's now going to operate fully uh, as a first class token. And a question from Kamuri, could you do a CBDC? Well, yes. I mean, this what I've done here is effectively creating an asset which is usable as a CBDC. So what do you need for a CBDC? You need a token which is transferable and secure, which is what these tokens are, and you need the right of at least one central bank or authority to mint, which is exactly what I've got here. Yeah, so I can mint my kebab coins, um, and literally everything you need for a CBDC on chain is available in this implementation. Yeah, so that's pretty much all you need, and I can do everything with everything I could do before, like transfer a token. So I want to do transfer. Um, let's say I'm sending it to account number 13 again. I want to send 555 tokens. Oh, sorry. Transfer kebab 555. So I've sent over some of those kebab coins, and my balance should have reduced accordingly. Yeah. So it's a fully functional token. You could use it as a CBDC. You could use it for payments. You could use it for um, credit. You could use it for derivatives. You could use it to denominate smart contracts. You could use it for bidding on a NFT. Everything you want to do with a token, you can do with these multi tokens. Yeah, there's fully functional. So yeah, why would you create a new actor, a new smart contract with custom code when you can just do this? It's super fast, it's super cheap. You can, create thousands of these things. Uh, I mean, I need to give them different names. That's the only slightly annoying thing. So call MT create one, two, three, etc. I could just go on all day and create thousands of tokens if I want. So this is the capability which lets us really have very fine-grained tokens. Yeah, and by fine-grained tokens, I mean like every single person could have their own personal digital currency. Uh, every single, uh, you know, uh, uh, every single shop could have its own loyalty reward scheme. Yeah, these because it's so cheap and it's so efficient to create new tokens, you might as well have lots of them for all the different purposes that make sense. Um, so, uh, and then the point about the universal asset model, it's exactly the same. Yeah. So just compare. If I want the balance of kebab coin, that works. But the one I created earlier, the full fungible token, my coin, that also works. Same function. And then if I go back to NFTs, these are the NFTs I hold. So it's exactly the same asset model, works on all of these different types of types of token. So another question: if you do create thousands, how much memory do you need on chain? That is a great question. Let's Okay, so let's test it. So I just typed in memory, which is the sort of memory allowance that I have in this account. So I've got a memory allowance of uh, nearly 10 million, which is plenty of memory. So that's basically 10 megabytes on chain memory allowance. So what I'm going to do is I am going to create a new coin test, and let's see how much memory I actually use. So I did create test, 11 bytes. So an entire new fungible token creation only used 11 bytes of on-chain memory. So that's pretty lightweight. Yeah, it wouldn't be a problem having a million tokens. It's only going to be, tens of megabytes. That kind of scale. Um, and a couple of reasons. One, the multi-token actor is designed to be super efficient with memory, so it's using the minimum amount of memory possible. And the second is there's a bunch of design decisions in Convex that make these things very efficient. Yeah. So the fact that we basically start numbering everything from accounts with a small number like 27 or whatever. Yeah. That's a very small amount of memory to have just a single, it's just like 1 byte worth of data for the value 27, and 1 byte for the sort of the tag which identifies the type of the data. Yeah, compare that to most networks where your identifiers are these very long hexadecimal numbers. I mean, just the address of a ERC20 token on Ethereum would be larger than the entire token on Convex. Yeah, because the entire thing is just 11 bytes. So Convex is designed to be super memory efficient, precisely because we want to enable people to have millions of different tokens or millions of accounts, and to make all of those things efficient. Um, Another question: SSI ID token. Yes. So by SSI, I assume that's self-sovereign identity. Yeah. Every single SSID could have its own token. No problem. In fact, you might even be able to get that to zero memory, because you could have a default token for each ID. Yeah. So this is the beautiful thing about the universal asset model. You can do all kinds of different implementations, but I could see an implementation that defines a personal token for every self-sovereign ID. And if you mint those, then it starts to track the balance, and it'll probably require to use a few bytes at that point. But if you don't mint any and the balances are all zero for everyone, then it just doesn't use any memory at all. It's just, you know, it's all just assumed to default to zero. So it wouldn't actually require any memory to store that. So you could, yes, you could have a personal token for every DID. Yeah, if you think about a W3C DID, each DID gets its own personal token, and that's a perfectly reasonable implementation on Convex for, you know, millions of personal tokens. Now, would you want to tie a token one-to-one with a DID? I mean, that's a design question. Yeah, does that make sense? I mean, it might do for some applications or use cases. It might not for others. Yeah, because it might be that a single person might want to have 10 tokens, so it wouldn't make sense having a sort of one-to-one mapping. But again, this is a design decision for people building these capabilities in the ecosystem. So you've got a lot of flexibility in that. I mean, if people are interested, I mean, I can't really do it now because it's a little bit more involved. But if people are interested and drop by the Discord, I can explain how you might build that, how you might build a token implementation with, you know, potentially millions or billions of different tokens, and how that would work on Convex, because it's definitely something that we've thought about in terms of the design, yeah, because we want to enable these kind of innovations. I'll give you another example: derivatives, yeah, put and call options. So if you imagine derivatives, they have like a number of different parameters, yeah, like a what is the underlying asset, what is the strike price, is it a put option or a call option, what's the expiry, and there may be a couple of other parameters. But basically, you've got a financial asset which is parameterized with a number of different parameters, including a reference to um, a underlying asset. Yeah. Now, that might require you having hundreds of thousands of different configurations of options, put options, call options on a single underlying asset. Yeah. So if you've got a well traded you know, public company, its shares might have many different derivatives, different maturities, different strike prices, etc. Yeah, and people might want to issue those. They might want to redeem them. They might want to, you know, do all kinds of things with these derivatives. Now, that could be a very large number of tokens. If you imagine each derivative being a fungible token where you can buy and sell put options and call options, that's actually a lot of individual tokens. You wouldn't want to be in the position where you're, for every single underlying asset, you're creating thousands of new tokens with separate smart contracts, separate actors to manage them. It would just get extremely expensive and cumbersome to manage all of that. So what do you do? Well, what you would do in Convex is say, okay, I'm going to define an asset, and let's call it the option asset. Yeah, and that's going to be an actor. We have one actor which implements options, and then the the remainder of the identifier of the asset is going to be, okay, it's a put. It's going to have a strike price of some of that, and it's going to have an expiry of some timestamp. Yeah, let's make it in a few years' time or whatever. Yeah. Um, so that kind of asset, I can identify the asset by having these parameters. Yeah, what are the parameters of the derivative asset, and what's its expiry time? And this option actor can create these derivative contracts on demand. So I don't need to create new actors. This single actor can handle millions of different derivative contracts. Um, and if you want to mint that particular configuration of I need an underlying. So I need an underlying, don't I? So maybe it's my coin. It's the underlying. Yeah. If I want to create these options, I can do so just by asking the actor to issue them, and maybe I've got to deposit some my coins in order to have a tradable option. But that's all possible now with the universal asset model. So you can have quite sophisticated contracts and assets that use this same model. So hopefully that's given an idea of some of the power of the asset model in Convex, and some of the opportunities that it opens up to really create more advanced classes of digital asset, and in the sort of the economic systems that depend on those assets. Okay, so I think we're about coming to the end of the hour. I mean, I hope people have found it interesting. Thanks for all of the great questions. Let me just scan and see if there's any other questions that I missed. People asking if we'll be offering to reserve names when we go live. Yes, there will be a way of buying user names in Protonet. So you'll be able to say, I could have user.mike or something like that. The exact process for doing that hasn't been finalized, but we will be offering a name registration service. And you'll be able to buy with Convex coins or some other token. So there'll be some like nominal fee for reserving names. Any other questions? Could you have 1 billion accounts? I mean, yes, feasibly. Yeah, accounts in Convex don't use that much memory. So 1 billion is a lot, but it's within the realms of possibility with modern hardware. So yeah, would definitely be possible. Okay, I think that's all the questions that I see in the chat. But thanks for all of the comments and questions. And as always, feel free to drop by the Discord if you want to discuss any of these things in more detail. So thanks everyone for joining, and see you next time. Bye for now.